Welcome to No Code Malware Windows 11 at your service. Hello, BSides Orlando. Hi everyone. I'm excited to be here at BSides Orlando and welcome to No Code Malware Windows at your service. This talk we're going to be focusing on how do you take Microsoft signed executables, services, and cloud services and turn them into your own malware operations. Hi everyone, I'm really excited to be here at BSides Orlando. Hi everyone, I'm really excited to be presenting this talk in BSides Orlando, even though it's virtual. This talk is going to be fun. We're going to show you how you can take Microsoft signed executables, local services and cloud services and turn them into your own malware operation. A little bit about myself. I've been in this space of low-code, no-code security for the last 4 years now. About 2 years ago, I co-founded Zenity, we're a company focused on security for low-code, no-code apps. I've spent a bunch of time at Microsoft, really all around security with the IoT and API and infrastructure as code and application security. I also lead a project, an OWASP project dedicated to low-code, no-code risks, and so you can find us out there. There's a whole bunch of information we're putting forth, and I write in dark reading again about low-code. If you find the subjects of this talk interesting, if you want to talk more, please reach out to me on Twitter. I'd be happy to chat. So this slide is important because of course we love no code. We think that it's great. It's empowering people to do things that they were not able to do before, but it needs to be done in a secure way, and that's why we are giving this information kind of from the attacker's perspective. So here's what we're going to start with. The idea is we want to create a malware operation. So from the time that you were able to get initial access to some machine, to when you have a full-blown malware operation operating and working, and you can send commands, they come back to you. There's a whole bunch of work you need to do. Let's just figure out what exactly do I mean by malware operation. So let's say that you got initial access to some victim machine. That's really cool. That's the first part. But now there's a whole bunch of ops that you need to do in order to actually kind of take advantage of it. So this is kind of the real world where that's fine that you have initial access, but there's a lot of things that you need to deal with. So you need to be able to actually run something on that machine. You need to be able to communicate with the command and control, perhaps through a firewall. You need to be able to exfiltrate data back, again, through a firewall. You need to be able to avoid detection either by EDR or by network tools or any other thing that kind of that security teams are putting forth to block you there. And you also need to remain persistent because you want to stay where you initially got access to. So all of those things that are not hacking, they're actually grunt work. That's a bunch of operations, a bunch of things that you need to do after the initial access that are kind of about engineering and creating this architecture where everything is covered up. The idea behind this talk is to try and find someone else that will solve these things for us, that will solve all of these operation things for us. And in order to do that, let me introduce kind of a service that has been available for quite some time out there. RPA. So I'm not sure if you've heard about this, but RPA is a new product category, relatively new, a few years, and the main value proposition is for users to automate mundane tasks. So this is basically copy and paste integration, processing receipts, onboarding and offboarding users. Basically, there are three components to this technology. One is an agent that sits on people's laptops, and it's actually using the basically emulating a user, so performing screen keyboard operations or mouse operations. So that's one thing. The second piece is the controller. This is something that is actually able to reach out to the machine, to the user machine, and the agent within it, send out a command to be executed, and then after the command is executed, get the results back. And of course, there's a management portal that allows you to do this at scale across multiple different machines. Now, the crucial piece about this technology is that every one of these points, every one of these services are trusted. The executables, the agent is trusted on the user side. The controller that is able to reach out through the network, send a command, and get the results is trusted by network security, and the cloud services are trusted as well. And so this gives you kind of a feeling into what are we going to do next. Now, RPA is really everywhere, specifically in the enterprise. And you're seeing a bunch of different, the leading RPA vendors in this slide. These are technologies that are used across the enterprise, and we'll see this in a moment. But you can expect these agents to be there on almost every enterprise laptop today. We'll see in a moment why. And so most of this, let's continue on. And so RPA can handle everything that we just saw for us. So it's able to do command and control exfiltration, defense evasion, persistency, cleanup. These are all things that we will show how to accomplish through RPA. But it will also provide a bunch of other things that we didn't ask for, like that are about engineering, basically, supporting different OSs, being able to update, handling errors. And so this is really empowering for us, and it's a very for hackers, and it's a really good place to live off the land. So because there's a lot of capabilities and they're trusted. So you already see where this talk is going. So now when we are kind of all on board with what we're going to accomplish, let's look at what we're going to do today. So first of all, we just talked about malware operations and what this is. We're going to dive deep into what RPA is to just kind of figure out that we're all on the same page and that we understand what this technology does. Next up, we'll do a technical deep dive. How does it work? How does it accomplish what it does in order to be able to take advantage of it? And then we'll switch gear and actually show all the things that we have mentioned that are kind of the part of the grunt work of malware operations, how you can do them with RPA. We'll introduce a tool that does all of this for you without having to know the complexities of RPA. And don't worry, I'm going to also send you home with a few points of things that you can do to protect your organization. So let's start with RPA. In order to figure out what RPA does, let me start off with a story. When I was a teenager, me and my friends used to play in a very nerdy game called Tibia. Basically, it's an MMORPG where you level up, you play with other characters. It's a very kind of social game, and we were obsessed with this game with me and my friends. But actually, a lot of the things that we had to do in this game, a lot of the day-to-day, involves things like fishing. And so what do I mean by fishing? Basically, you take a worm and you click on the pond and you might get a fish. And this kind of leveled up your fishing skills and was important. This was like 90% of my time playing the game. So you click and you get fish, and you click and you get fish, and you click and you get fish. And I mean, it's nice, but actually it's really boring. Because you are basically transforming virtual worms to virtual fish. This was annoying and kept me away from what I really wanted to do. So I wanted to find basically an advantage, a creative solution to figure out how to do this without having to invest the time. I also wanted to kind of impress my friends and gain an advantage over them. And so I came up with this kind of creative solution. And this is true, by the way. I didn't find the real photo, but I used physical automation, and so this is an illustration of how this looks like. Basically, I would put a bunch of books over the keyboard and the mouse overnight, and then I hoped that by the time morning comes, things would still stay there, and I would level up. This kind of worked some of the time, but most of the time things fell over, things didn't behave as I expected, and of course this was very limited in what I was able to do. And so, but this did trigger my imagination into what is actually possible. And so in the next iteration, I actually found a few kinds of software that were able to record my keyboard and mouse, and then just reiterate those steps over time. And this is this was very sophisticated for me at the time. Let's see how it looks like. And so you can see that now I am able to do much more than just click. I can move the mouse around, I can move the character around, and so this was a revelation. This made me basically the hero of my friends, because more than just being able to do this, I could share it with others. And so this is a nice way to kind of think about RPA. RPA is a technology that has started as a way to create integrations by emulating a user one-to-one. This also means that you can integrate with systems that don't have proper APIs. Think about kind of legacy software in a large enterprise. And so you can just, by being able to use the computer as a user would, you gain access to the same kind of things that a user would be able to do. And so here's a quick summary about what RPA is. The idea is to replace this copy and pasting that users do manually. The building of RPA tasks is very much kind of drag and drop. It's supposed to be easy to do by everyone. You emulate the user actions, and so the mouse and the keyboard. This also means that you run the same way as the user runs, right? You run as the user. There's no way, unless you're doing some behavioral analytics, to distinguish between a user and an RPA bot. And again, this distinction would be very difficult, because this is exactly what the RPA is doing, is emulating user activity. And also, RPA runs either on user machines, so on user laptops, in order to be able to access the same kind of information that they're accessing, or on dedicated servers. And this is actually being used for really heavy lifting within the enterprise. There are serious use cases, for example, automating offboarding and onboarding employees, submitting financial reports. So there are a bunch of things that enterprises are doing with RPA that are really creating a lot of value. So now that we understand why RPA exists and why is it used in the enterprise, why today in almost every enterprise you'll find RPA there, let's kind of dive a bit deeper and figure out how it works. So that's what we're going to do right now. And the rest of this talk from this moment forward is going to be focused on Microsoft's RPA. It's called Power Automate, and all of the things that I'm going to show you are very similar across different RPA vendors. It's not really just a Microsoft problem. It's an RPA. It's inherent in RPA. But the reason why we focus on Microsoft is because Microsoft's RPA agent comes built in Windows 11. And so if you open up a Windows 11 machine, a vanilla Windows 11 machine today, a laptop, a server, you'll find Power Automate already there. And that's why it's important, because it's kind of available for us to use. Let me show you how this looks like from a user's perspective. And so when you kick off a new vanilla machine, Windows 11, just search for Power Automate. You already find this agent within your machine. Let's see if this works. So I'm going to show you what happens when I execute this agent for the first time. Okay, so I'm going to Power Automate. First of all, it's going to ask me for an email address. This is a Microsoft address. And keep in mind, I could plug in any address here. That's important to note here. Once I do that, it connects to Office, and then you can see a whole bunch of information being populated. We'll jump back to it in a moment. I'm going to create an hello world application, and now you're seeing the actual the builder, the drag and drop interface that allows you to create RPA bots. I'm going to choose the write to file action and just pick the file that I would like to write on, and you'll see that very quickly I set up a flow which kind of appends a line into this file. I click on run, it runs, and everything gets executed really easily, and the file gets created. So you can see that this is pretty easy and that there are a whole bunch of applications I can use. You can also see that there are other tasks that are already available because of the integration with Office. And as you can see, there's a little trigger there that the thing actually worked. And so you noticed, and I kind of stressed it a few times, that first of all, when you connected, you had to use some sort of an address, and then afterwards, you got a whole bunch of automations that were already available there. So let's figure out what's going on there. This is actually what we saw, right? So once we plugged into, we added our address or logged in to Power Automate, you saw all of these different automations that were already available, and those are my automations, so I created them in advance, but not on the machine. I created them on the Office side. So that's exactly, you can see that in the environment, on the environment widget there. Basically, Power Automate is connected to Office, and it drives all of these automations through Office, and that's why you're actually seeing this. So this is synced with the cloud. And so one thing that you should be asking yourself is, how is this possible? So if let's say that Microsoft is, so we understand that Microsoft is putting this in by default, this agent, in every Windows 11 installation. And this is connected to Office. But it's not like they asked some network admin in the middle to open up the firewall, right? This is something that needs to work properly. So let's figure out how everything works here. So on one side, we have Power Automate. It runs probably on-prem, but on somebody's machine. On the other side, we have the Office Cloud Services. And before we talk about the communication, let's just figure out what's actually happening on the user side, on the laptop side. So Power Automate is actually more than just one executable. There's a whole bunch of executables that are available within the Power Automate framework inside Windows 11. The two important ones that I'm showing you right now is the Power Automate executable that actually runs the command, and it runs as the user in the user context. So the same kind of permissions, everything like the user. And the other side is the machine runtime. It runs on a service account created in your machine by Microsoft, again, every Windows 11 machine, and it runs in parallel to the user, and this is going to be the piece that actually connects to Office. We'll see that in a moment. Power Automate is also able to automate the browser, and it does so through a whole bunch of browser plugins, and those are available for browser extensions, and those are available to every major browser. So there are dedicated executables that actually handle this, and so I added them to the picture here as well. And just kind of so you know, the only thing that I just showed you right now are these three executables, but actually, as you can see, there are a whole bunch of executables that are available as part of the Power Automate directory. If you're looking for a nice place for research and to dive deep, I really recommend this. There's a whole bunch of work that could be done here. And the one thing that is important is that all of these things, as you can see, it's part of the kind of, it's already there in program files. It's also supported by the trusted by the EDR. And so, because this is part of Windows 11, Microsoft's EDR and others as well are trusting these executables to be okay, to be something that Microsoft has put forth. So now that we understand what's happening on the user side, let's try and understand the network. So how does this communication actually happens? Microsoft did not go out to each network security team and ask them to open up the firewall so every user to be able to directly connect to Office. What exactly is going on here? The way that this is accomplished is with a cool solution called Azure Service Bus. It used to be called Azure Relay. basically there's outbound communication going from both sides, from Office and from the machine runtime, which is actually the user's laptop, and it goes and there's basically a message queue there with commands that the agent should be executing. And so the agent would go out to this queue once in a while, fetch new commands, and every time there's a result, it would just save it on that queue again. So that's the way that the communication is being established. And so now that we're connected between the agent and the cloud, let's try and figure out how does it look like from the Office side. So what exactly do you see there? So there's a very nice layer in Office that allows you to look at these agents, understand what they're doing. You can see all of the machines that I have registered into my malicious tenant. You can see the version of the agent being installed, whether it's working or not. So essentially, this is a management portal that allows you to view all of these agents. You can also run commands directly from the cloud. So in the same way that you saw me a moment ago create an automation on the user's laptop, you can actually create it somewhere else and then move it to the cloud and trigger it on some other user's machine. You can also view the status of tasks. So you can debug failures. You can check out when things happened last. You can rerun things. So everything that you need in order to actually manage things, manage these agents at scale, is available through Microsoft Cloud. One thing that I still want to touch on is the trust component here. How is trust being established between Office and the users and the user agent without other than the authentication? So the messages that are put on these. So once the registration part happens, and you saw me do this a moment ago, there's a private key being created on the machine side, and the public key is being sent through that mechanism to Office. And then with this private public key, the Azure Service Bus, the messages can be signed, and when they're signed, keep in mind that they have two things. One is the RPA task, which is actually kind of what needs to be done, but they also have local credentials, and this is important. This means that the machine runtime agent can run things on behalf of the user of the user that already exists in that machine, but it can also run tasks as any other user. And so this is how this process is being done in a secure way. And so, in a nutshell, users can build custom processes. They hand them off to Microsoft. Microsoft then ensures that these processes are distributed across all of the different machines that run that are registered to your tenant, executed successfully, and then report back to the cloud. And so I think you can realize what I'm about to do next. So let's just do it. The next part would be, how do you take everything that we have learned so far and build a malware operation out of it? And so let's recall our wish list. These are the things that we wanted to do, and we're going to go one by one and achieve each and every one of them with Power Automate. And so let's start. The first thing we need to do is to set up that malicious tenant. We need to set up an Office deployment that would be the one we are using to manage all of those agents. And so you can see that very easily here. I create a tenant. This is free. You don't need a license. You don't need to provide a credit card. So this is kind of very easy. And once you create that tenant, when you go to the Power Automate interface, you'll see that it points you to install new machines, or basically to onboard new machines in your tenant. So how exactly is it happening? We actually saw this earlier. So there was a quick UI there. You sign in and you can add in your own email. And remember, I alluded to the fact that you can that you can plug in any account here. This is exactly the point. You can see that I'm inserting an account that is part of my malicious Office deployment. But of course, doing this with UI is kind of fishy. We don't really need to do that once we have initial access to somebody's machine. We want to be, of course, we want to hide. And so, fortunately for us, Microsoft provides a nice script, silently register a new machine, that allows you through PowerShell or through command line to register a machine to your own tenant. And by the way, even if that machine is already registered to somebody else's tenant, to the actual organization tenant, it doesn't matter. It can be registered to two tenants in the same time, and nobody else, and those won't know about each other. And so this is really cool. It kind of solves our problem, right? Once you do that, you will be able to see the Windows, the machine that you've just registered in the Power Automate management interface in Office. And so this is the way that we onboard new users, i.e., this is the way that we infect a new machine. One thing that you might have noticed there is that this script the script needs to be run as an administrator, which of course is not that great, right? As a hacker, this is very limiting, and so we try to poke around and see whether we can get it to run as a user and not just as an administrator, and actually it just worked. So we just tried and it worked, and so you can also run this executable as a user. It will register your and it will still register the machine to the malicious tenant. And so we have so once we have that, the machine is registered to my malicious organization. And now, in order to actually run something on that organization, on that infected machine, here's what I have to do. So I trigger something from the cloud. I create this automation from the cloud that chooses a specific desktop flow. That's the name of the payload that I would like to run. It uses it asks me for the credentials, as we mentioned earlier, the local credentials, which again we assume you already have because you have the initial access. And then it distributes the payload then you basically choose the payload and it will distribute it to the machine. And now, of course, you can run this on one machine or you can run this on many machines. One thing that is important to question here is what about this user Alex G? What happens if they're already logged into their machine? What happens if they're actually using it right now? So how would it look like from the user's machine, from the user side? Fortunately, RPA has already taken care of this, or Microsoft have already taken care of this. So there are two versions of RPA, attended and unattended. Basically, if the attended means that if the user already has a session ongoing within the local machine, you just join that session and you run with the user on the same session. Of course, it means that you can steal secrets, you can do everything that the user does. And the other option is unattended RPA. This creates a new session and then discards of it when it's done. And so we can do both of these things. And so you can see that RPA has already taken care of many edge cases for us. And even more than that, we have already showed you 3 things that we wanted to do. So deploying malware, that's just running the script, the Microsoft script. Defense evasion, well, this is obvious. All of these services, the executables, the cloud services, they are all trusted. They are trusted by Microsoft, they are trusted by other security vendors, and so defense evasion is already there. And with persistency, keep in mind, we haven't installed anything new on the machine. This was already there. And so you can always just run the command back from the cloud and run things on the machine, even if somebody tries to kind of because there's nothing really to remove. So next up, we are going to see command and control. We did see a couple of these of payloads that we sent forth, but let's kind of figure out what kind of payloads we can send and how can we make it kind of generic. So now we're going to see, once we already have a machine infected, we can already send commands out. Let's see what actually we can do. So here's just a simple example, data exfiltration. So this is a simple automation. I'm giving this automation as inputs the target file, some local file I'd like to exfiltrate, and then I'm getting back the content of that file. And you can see that there's also error handling here, but that's kind of very, very simple. Let's just make sure we understand how this works. First of all, from the cloud side, you can see that I can run this automation. I give the input target file, and then I just get it back. Let's make sure we understand how exactly does this data exfiltration work to make sure that we won't get caught. And so if you recall the architecture, let's and figure out what's happening over this architecture. So creating those instructions, basically creating the payload, happens with us directly with Office. And so we reach out to Office, we give out this payload, and then we give out the command, send this payload to a specific machine. That command goes through the Azure Service Bus, this channel of communication between the user machine and Office, and it's being executed. It reaches the machine runtime, which will execute it with one of the Power Automate agents, depending on the user. Once the information has been collected, it will be written again on the secure communication between Azure Service Bus. And so you can see that from the enterprise perspective, from the network perspective, you really cannot catch this because it's going to Microsoft trusted services. And so I just showed you data exfiltration, but actually we want more than that. We want to be able to run every command that we would want on the user's machine. Let's see how to do that. So here's the first version of code execution. Basically, there's a bunch of nice utilities within Power Automate that allow you to basically run a command on the machine. So you can see that I'm getting as input a command, and I can run it as PowerShell, as Python, as JavaScript, so there are a bunch of options. And so using this, I can send any payload that I'd like into the machine. The problem is that once I execute this, I get caught by the EDR. And why? Well, because I just ran a malicious payload, in this example, trying to use Mimikatz. And of course, this can be caught by the EDR. I mean, EDRs are monitoring this. Essentially, there are two parts here. So the part that is trusted is this drag and drop interface. What the agent, the RP agent is actually doing. But once you go to other processes, once you spawn a command prompt, well, of course, this is something that EDRs are especially worried about. So it makes sense that we get caught. So the question then becomes, what can we do if we stay in this trusted zone? Can we take better advantage of the trusted zone to actually execute what we want to what we wanted to execute? Because the trusted zone, what we already have there, does have some logic, right? It needs to choose the right kind of interpreter or compiler or something that we need that we're using to actually run the code. And so what can we do to take more advantage of it? And so let's see how it works. When we run this, when we created this payload, you can see that there are a whole bunch of commands of operations that we used in order to create it. And so the question becomes, what payloads are available? What can we do with them? So this is just a little snapshot of things that are available within kind of as ready-made operations. So you can use crypto to encrypt files or to encrypt files or to encrypt content. You can trigger HTTP calls. You can communicate with AD, with Windows services, with other processes. You can look at files and folders. You can automate a browser, which we'll see in a moment. You can take screenshots. You can use the mouse and the keyboard and record them. So keylogging is easy. You can copy the clipboard or change the clipboard. And so I'm sure your mind is racing right now with the kinds of things that you're able to do. Basically, these are all of the primitives that you need to accomplish most of the things that an attacker would like to do. And so let's see a few of those in action. So let's start with a simple example, no-code ransomware. So here's this example. I'm basically focused on a specific directory. I'm going to crawl that directory and the subdirectories, and then I'm going to encrypt to replace each file with an encrypted file. You can see the automation here is again pretty simple. There's a bit of error handling and a bunch of for loops, but basically I just go deeper and deeper into the directory hierarchy and encrypt each one of the files. Let's see a quick demo. So this is the cloud side. I'm providing the encryption key, the directory, and how deep do I want this to actually go. Deep within the directory structure. The flow is running. The command is right now being sent to the malicious agent that is going to run this on the infected machine. And you can see that it's already run, and it's given me information about the actual execution. On the machine side, you can see that the files are actually encrypted. And so this is, as you can see, very easy to actually accomplish. Okay. One thing that we haven't discussed so far is the fact that there are a bunch of logs that this agent on the local side is generating. So the agent, the local RPA agent, is generating a bunch of information about what it's doing. Of course, we would like to clean those up, and it's kind of easy because we already know where this agent is actually storing information, and so this automation simply cleans up after ourselves. So we just go to every location where we know that the agent is storing information, and we're just permanently deleting those files. So we saw data exfiltration, we saw ransomware, and we saw cleanup. One thing that I kind of hinted on earlier is that RPA or Power Automate is also able to automate the browser. And so by automating the browser, of course, we can continue on our attack to other locations. So let's see how it looks like. Essentially, the idea is very easy. I would like to basically steal tokens for authenticated tokens, because we're running as the user from the browser. So here's the idea. We open the browser kind of in a way that the user won't notice. We go to a specific location. In this case, we're going to flow.microsoft.com to steal a Microsoft token for that user, and then we simply extract the token. And so let's see this in action. Here's the automation. So I'm going to launch a new browser, send out a few keystrokes to make sure that we get to the right page, and that we can kind of fetch its content. And then I'm just going to parse the results and fetch the authentication token out of it. And in this case, so you're seeing a Chrome app opens up on a Microsoft website, and the token gets exfiltrated back as an output variable. Now, of course, we don't want the browser to pop up in such a way. Remember, we're running as a user in the user session to steal their tokens. There's a very easy parameter we can change here to have the browser opened in a minimized version, so the user won't notice. Let's see how it happens from the cloud side. And so from the cloud side, we create a new request that basically sends this payload to the infected machine. Again, you saw this earlier. So the payload is being sent through the trusted channel, reaches the agent. The agents verify that it actually runs successfully. And from the infected user side, nothing happens. Because, well, we created this in a way that won't actually do anything on the user side. And so you can see that this is very powerful. So there are a whole bunch of things that we can actually do in order to basically everything that you would have wanted to do with data, as an attacker, you can actually do with no-code primitives. And so we saw command and control, data exfiltration, cleanup. We saw harvesting credentials through browsers. But there are actually a bunch of other ideas we didn't have time to implement, like creating a keylogger or any other thing. So please feel free to kind of play around with it on your own. And in order to make it easier for you to play around with it on your own, let me introduce PowerPoint. So PowerPoint is a tool that abstracts away all of the complexities of that I've just described, of how do you infect these machines, how do you send the information out there, how do you set up that Office account, so you can use all of these tools as part of your Red Team arsenal. PowerPoint also handles a bunch of things for you, so we handle errors for you. We also allow you to run all of these payloads through an HTTP trigger, an HTTP webhook, so an HTTP endpoint, rather than the need to actually go and log into Office. So here's how it looks like. Basically, you post to the HTTP endpoint that is created for you. You choose the infected machine and the user you want to run as. the actual payload that you'd like to run and the parameters, and you'll just get back all of the output as all of the results of that payload as output or as the return side of the request. There's also a convenience layer in Python that you can use to make your life even easier. So you can execute commands, run all of the payloads that you saw here today, and actually others as well. We're fortunate enough that there's a kind of a small community that has started to be built around PowerPoint. So check it out. You'll also find all of the instructions of how to set it up on your tenant. And of course, the idea here is to use this tool basically to first of all to learn yourself about the space. After that, to kind of teach others and gain the attention of management, and of course to build defenses around these capabilities. And so, a quick summary into what we did today. We saw what RPA is. We saw that RPA is available in every organization, and we did a very technical deep dive to figure out how exactly does it work and accomplish what it needs to do. And the important thing here is it doesn't require the acceptance of management, or it can just be plugged in there by the vendors themselves. We saw that you can use RPA as basically as a way to do remote code execution as a service. To take care of all of the grunt work for you. You can distribute payloads, execute them, make sure they run successfully, and everything works through trusted services, trusted executables. We haven't installed anything new, and so this would be very difficult to catch. You also saw that the no-code primitives that are provided by RPA are actually pretty good. So there are a whole bunch of things that you can do with those primitives. We saw PowerPoint, which is a way to do all of that, but without having to deal with the complexity of RPA itself. And instead, you can run with command lines and Python interface. And the last thing I want to do before we finish off this talk is to send you home with a few things that you can do to protect your organization right now. And so these are concrete things that I encourage you to do. First of all, you should monitor for every event of registering this Power Automate agent silently on user machines. So there are a couple of executables that I'm stressing out and pointing to here. Every usage of those executables should be monitored and logged. And more than that, if you can create a detection that identifies usage of those executables with a tenant ID that is not your own organization's tenant ID, like the malicious tenant that I created for this talk, for this research, this would be a very critical sign that somebody is actually trying to use these methods to hack your organization. I also encourage you to review Microsoft's documentation around Power Automate and try to. There are a whole bunch of things that they're suggesting there to basically try and reduce your risk. And there's a bunch of information about no code and the risks around them. There's a whole bunch of links that I've added here. This entire talk was focused on how an attacker can take advantage of RPA, but actually users that are using RPA are also exposing organizations to a whole bunch of risk. This is the subject of another talk, so I'll leave it for another day. Thank you very much for listening and tuning into this talk. I'd be very happy to continue this, to make this into a conversation later on, so please reach out to me. Thank you very much and have a great conference.